Let's look at question B on partial fraction. In this question, we have to express 1 over m plus 1 in partial fraction. First of all, we recognize that this is already a proper fraction and hence no long division is required. Secondly, what do we notice about the denominator? Well, it is made up of two non-repeated linear factors, namely m and m plus 1. For those who might have forgotten partial fraction, you can actually refer to MF26, and in this case, the most relevant equation would be the first one, where we do see that the denominator is also made up of two non-repeated linear factors. So we have one here and one here. All right. Using this, we can then go back to our main question and we can write, let 1 over m plus 1 equal to a over m plus b over m plus 1. So essentially we are using our formula over here. All right. And we want to find the unknowns a and b in order for us to decompose the fraction as required. In order to do so, we can multiply throughout by m plus 1 to give us 1 is equals to a m plus 1 plus bm. All right, and we can then write this to become am plus a, so it's just expansion, plus bm. We can group the like terms together, so we have a plus bm plus a. Now, how do we find the unknowns a and b? In secondary school, we learned that we can actually compare coefficients. So comparing coefficients, okay, on the left-hand side, it is actually the same as having 0m plus 1, isn't it? This means to say that a plus b is equal to 0. So comparing coefficients, a plus b is equals to 0 and a is equals to 1. By solving these two equations, we get that b is equals to -1. But this is not the final answer because we have to sub back and express it in partial fraction. Therefore, 1 over m plus 1 is equals to 1 over m, and since b is -1, we can write this to be minus 1 over m plus 1. And this is our final answer. Well, why are we doing partial fraction? This is because partial fraction is quite typical in questions involving methods of differences, and hence it is included as part of sequences and series.